In section 5.8, you will analyze graphs of polynomial functions. So in this section, we'll be graphing again, and we'll be concerned about finding x-intercepts and local maximum and local minimums for these curves. The first function we're going to graph looks like this. The function is given in factored form. So first thing we should do is analyze the end behavior. And since it has a negative leading coefficient, and I'm just going to abbreviate here, a negative leading coefficient, we know that it's going to fall to the right. And because the degree is third degree, if I multiplied these binomials out and distributed, I'd end up with a leading term that's of the third degree. So the function is of the third degree, and that tells me that the curve is going to have opposite behavior left and right, opposite end behavior, and also it's going to tell me that this curve is going to have at most two turns, the degree minus 1 and minus 1. So at most two turns is what I can expect. So now to begin graphing, let's find those x-intercepts. We'll let y equal 0 and we'll solve for x using the zero product property. And when we do that, we find that those x-intercepts are going to be -2 and +1. So I can graph those, -2 and +1. And now because I have a factor of the form x minus k raised to an even power like we learned in the last section, I can expect this curve to be tangent at that 0. It's going to be tangent to the x-axis at 1. So since it has to fall to the right, I know it's going to be coming up and touching or tangent to the curve and then or to the x-axis and falling to the right. Now the curve has opposite behavior left and right, so I know that it's going to pass through this 0 and rise to the right. But what's happening in between? That's what I need to find out by making the table of values in between my x-intercepts. So I'll let x equal -1 and 0, and I'll solve for y. If I let x equal -1 in my function, I have -1 plus 2, that's 1, and I have -1 minus 1, that's -2 squared. So -2 squared is 4, and 4 times -1 is -4. Letting x equal 0, I'm going to have 0 plus 2 in parentheses. That's going to be 2, and 0 minus 1, -1 squared. -1 squared is 1, and 1 times -2 is -2 for a y value. Okay, so now I can graph those points. -1, -4, 1, 2, 3, 4, and a y-intercept of 0, -2. So I see that this curve falls to this local minimum and then rises to its local maximum. Okay, so I want to list those local maximum and minimums. And the local maximum is going to be found at 1, 0, a high point for the curve in that area. And our local minimum for this curve is near -1, -4, a low point for the curve in that area. Okay, so we've listed the x-intercepts for this curve, and we've listed the local maximum and local minimums. Okay. The next function is h. It's a quartic, and we're going to graph and locate those same x-intercepts and local maximum and local minimums. So let's discuss the leading coefficient. It's positive. Now that's going to tell us that the curve rises to the right. Okay, and the degree is 4. It's even. So that's going to tell us that this curve has the same behavior left and right, same end behavior. And it also is going to tell us that there's at most 3 turns, n minus 1 or the degree minus 1. We can expect at most 3 turns. Okay, we want to locate those x-intercepts again so we can begin graphing. And this time our function's not in factored form, so we're going to have to factor it. We're going to let y equal 0 and factor this quartic. Well, it's a polynomial in 4 terms, so the only thing that I can do to factor this polynomial is look at possible rational zeros. And my p-values are factors of 4, so that's plus or minus 1, plus or minus 2, and plus or minus 4 in the numerator of these possible rational zeros. In the denominator, q is factors of the leading coefficient, which is 1, so just plus or minus 1. So I'll begin my synthetic division here through the coefficients 1, 4, 3, -4, and -4. Every degree is represented. I'm going to start with 1 to see if that's a 0 of this function. So I'll add and multiply. Add, multiply, 1 times 5 is 5. Add and get 8. 1 times 8 is 8. So I'll add and get 4. 1 times 4 is 4, and I do get a remainder of 0. So I have found a 0 of this function, and I can begin factoring x minus that 0 of 1. Okay, what's left here is x, it'll be of the 3rd degree, 1x cubed plus 5x squared plus 8x plus 4. Okay, now grouping's not going to work on this polynomial in 4 terms. My constant term is still 4 and my leading coefficient 1, so I have the same list of possible rational zeros, and I'll try -1 through the new coefficients 1, 5, 8, and 4. So I'll put down a 0 and add. I'll multiply, add. -1 times 4 is -4. I'll add and multiply. -1 times 4 is -4 again, and I get another remainder of 0. So I found another 0 of this function. So x minus that 0 of -1 gives me x plus 1 as a factor. And what's left here, the quotient, is 1x squared plus 4x plus 4. And now that trinomial should factor into a binomial times a binomial. It looks like a perfect square trinomial. Factors of 4 that add to give me 4 are 2 and 2, and making them both positive, I find that 2x plus 2x is going to give me 4x in the middle, and positive 2 times positive 2 is positive 4. So those are the correct factors, and now this function h is completely factored. Okay, and I find that my x-intercepts are plus or minus 1 and -2. And now because I have that binomial raised to an even power again, x minus k raised to an even power, I also know that this curve is going to be tangent at -2. Okay, so I'll graph those x-intercepts. Plus and minus 1 and -2. Okay, now I know that this curve rises right, and it also rises left. And I know it's tangent at -2, so it's got to fall and touch. And then what I need to know is what's happening between those x-intercepts again. So in my table of values, I'm going to let x equal -3/2, and I'm going to let x equal 0. Well, when x is 0, I can see that my h value is -4. Okay, and now I need to find h of -3/2, so I'll substitute -3/2 in for x. So I have -3/2 raised to the 4th power. I have 4 times -3/2 cubed, and 3 times -3/2 squared, and -4 times -3/2 minus 4. So simplifying, beginning to simplify here, -3/2 to the 4th power is going to be +81/16. And second product is going to be 4 times -3/2 cubed is -27/8. And my third term is 3 times -3/2 squared, which is going to be 9/4. And -4 times -3/2 is going to be a +12/2 minus 4. Now to add, I'm going to need a common denominator of, and my common denominator is going to be 16. So I want to write all these fractions as 16ths. Okay, the second product has -4 times 27 on the top here, which is -108/8. And if I'm going to write that as 16ths, I'm going to multiply top and bottom by 2. So it looks like I'm going to get 216/16 for a second term. And my third term is 27/4. And to write that as 16ths, I need to multiply top and bottom by 4. So 27 times 4 is going to give me that 108. And then I want to write that fourth term as 16ths. So I'm going to have to multiply top and bottom by 8. And 8 times 12 is 96. And the last term, 4/1, I'll multiply top and bottom by 16 and get 64/16. Okay, now adding my +16ths, I'm going to get 285/16, and adding my -16ths, I get a total of 280/16. So subtracting, I find that my y value here is 5/16, which is real close to 1/4, because 4/16 is 1/4. So when I graph -3/2, 5/16, it's about there, and then my y-intercept of 0, -4 would be here. So I'm going to rise and fall to that low point. So this curve has at most 3 turns. It falls from the left and turns at that tangent point, rises to a local maximum, and falls again to a second local minimum. So let's list that local maximum of -3/2, 5/16, and the local minimums on our graph at -2, 0, and another one near 0, -4. So again, we've located our local minimum and maximums and our x-intercepts for this function, h. Include with your notes of this video guided practice problems 2 and 4 found on page 389 of your textbook.